All right, so we've spent a while working with expressions which didn't have an equal sign. Then we added the equal sign and did equations. And in this next part, we're going to talk about inequalities, which works similarly in a lot of ways, except for when you look at inequality, using your stems from language arts, right? In means not. So we're looking at things that are essentially not equal. So in the first box there, you can go ahead and type. Let's see, I'll zoom it in so you can see better. You could go ahead and type that an inequality is a comparison to things that aren't equal. And so when we do that, there's a couple things that we know about it. One thing would be that we use 4 symbols to do this, and we'll look at those on the next page. And the other thing we got here is that we can graph our answer. Well, let's see, we'll say we can graph all our possible answers. Because when something isn't equal, it could be more than and lots of numbers more than. So examples of this word or synonyms would be things like, I want to get you at least 2 pieces of candy. If this was just an equation and I said I wanted to get you 2 pieces of candy, you'd just be getting 2 and that's it. But when I say at least 2 pieces of candy, it could be 2, but it could be 5 or 20 or 100 or 1,000 or 1,000,000. Obviously, there's some real world limits on what it could be, but that's the idea. When we see it written out, a lot of times you'll see a variable, and then I'll use one of my symbols. This one's called greater than, and let's say 3. So things like that would be examples of inequalities. So things that are not inequalities are just numbers, like 4, right? Or equations are not inequalities, because when you have this equal sign, it doesn't mean that it's not equal. It means that it in fact is equal. So x equals 9 is definitely not an inequality. Go into your next page. Few basic ideas to fill in, especially reviewing the graphing idea here. So we can go ahead and right click, save to keep. Open in the new tab. And I'll click till I get the little pen. And here we go. So inequality, right? I'll just put the big part since we just wrote this stuff down, right? It's going to be where it's not equal. An algebraic inequality has a variable. So that's kind of the connection to what we've been talking about, right? And when you see the word solution set, that would be all the answers. So down here you can see there's our 4 symbols, right? We have this one, which is called less than. We have greater than, less than or equal to, and greater than or equal to. So we're going to look at a couple of words that would tip us off that it's going to be that particular symbol. So let's call this one, we said it was less than. And so words that you'll see that would tell you that it's less than would be things like under, below, fewer. So things like that. The other one that's right here then is its opposite, right? It's greater than. And for greater than, you might see things like above, over, more. So kind of the opposite of what we just filled in with the less than there. So when I look at those two, it means it can't be the number we're talking about, but it could be anything either less than it or greater than it, depending which symbol you see. The other two symbols are the same kind of thing. They almost look like the equal sign and the less than or greater sign had a baby, and this is what they made, where it had each of their qualities, right? So these two are the or equal to ones. So the first one would be less than or equal to, and the other one would be greater than or equal to. So when it's less than or equal to, you might see things like at most. So this is the most it could be, or maximum, or no more than. So kind of similar there. For greater than or equal to, same kind of idea, but opposite what we just did, right? So things like at least, minimum, and no less than would all be good examples. So when I go to graph these, I'm going to, and it has kind of a basic idea down here, use the number that I see, and then I'm going to make a circle on that number to tell you if it can be that number. So the first one says x is less than 3. So I'm going to find 3. I'm going to draw a circle. And I have to decide if it can be 3. So it doesn't say or equal to. So it could be anything close to 3, but it can't be it. So that's why I'm going to leave an open circle. Then I have to think about the numbers that are there. What's less than 3? Is 2 less than 3 or is 4 less than 3? It's 2, so that means it's all the numbers here. And so I'm going to kind of just darken this line to show it could be anything. So it could be any number that's less than 3, which means that it could be 2, right? That's an obvious one. It could be -8. It could be anything that keeps going in that direction. So it could be -1 billion. Remember, arrows tell us that it keeps going and going. But also any fractions or decimals in between 2. So it could get really close to 3, right? But not be 3. It could be something like 2.999999999, and it would still work because it's less than 3. In the next one, it's greater than -5. So find -5, draw my circle. Since it's greater than, it's not equal to, I'm not going to fill it in because it can't be -5. And then I got to figure out where are numbers that are bigger than -5. And so that one I could even look further. I know positive numbers are bigger than negative numbers, so I'm going towards the positive ones. For less than or equal to 2, I start off the same, so with a circle. But now that it says or equal to, it means it could be equal to. So I'm going to fill it in to show that it could be that number. And then I need less than or equal to. So again, I got to find less numbers. Negative numbers are always less than positive, so I'm going in that direction like this. So this one's same idea. Anything that falls on that line or in that direction would work. But in this case, so would 2 because 2 is filled in. So 2 could be an answer, 1 could be an answer, -10 could be an answer, and anything in that direction. Last but not least, x is greater than or equal to -8. So finding -8, draw on a circle. It is an or equal to, so it could be -8. So I'm going to fill it in. And then I need numbers that are bigger. So I'm going towards positive numbers, which is this way. Again, anything that falls in there. So things I can see like -4 or +7. Things that go way beyond like 1,432. Any fractions and decimals. And this one could be -8 because it's an or equal to. And that's the idea with it. So the graphing helps me to show that there's lots and lots of possible answers to this particular problem versus an equation that just has literally one answer for the most part. So go ahead back to my notebook, copy this in. And as you're going to answer the questions, go back to your notebook pages or go back in the video if you forget what some of these things mean.